When we do a Lewis dot structure for acetate, we find that in order to have the right number of valence electrons, there needs to be one double bond. So here's the skeleton structure. And over here on the right is where things get interesting, because this is where there are two oxygens bonded to one carbon, and one of them is a double bond, but there's no way to say which oxygen should get the double bond, because they're both equivalent oxygens. If we were to kind of rotate this molecule, then this oxygen would be on top. So what we have written here is a acceptable Lewis dot structure, but it's not the way the molecule actually looks. Here's another resonance structure, or another acceptable Lewis dot structure, where the other oxygen gets the double bond. So, and the top molecule, this oxygen with the single bond, to have a full octet, has to have 3 lone pairs. And when you calculate the formal charge, it must be a minus formal charge on the bottom oxygen. And the second structure here on the bottom, the oxygen with a single bond is again the one with a minus formal charge. So both of these are pretty Lewis dot structures, and in both of them all of the atoms have octets and there's the right number of valence electrons, but neither of them accurately represents what the real molecule is. What the real molecule really looks like is if these two Lewis dot structures got together and had a baby. It would be a hybrid of both of them. So the two resonance structures, their combination kind of yields a molecule where the double bond is kind of shared between both oxygens, and also that negative charge is shared between both oxygens. So there's like a slight negative charge on one oxygen, a slight negative charge on the other oxygen, and sometimes the negative sign is just written between the two oxygens. And so this is really what is a better representation of what the acetate molecule or ion really looks like.
Made with Doodlecast Pro.